All right, guys, so here's the review for matrix addition, subtraction, multiplication, and Kramers rule. The first part of the test should be pretty straightforward. We're just adding and subtracting matrices. So here, when you're given the same size matrices, and you can only add matrices the same size, we're adding consistent spots. 3 and -5, -2. 1 and 3 is 4, -2 and 2 is 0. 4 and -1 is 3. 3 and -3 is 0, 2 and 4 is 6. When you have the numbers outside them, we distribute through multiplication, and then we add. So when they distribute 3 through here, I get 12, -6, 3, 12, -15, 9. When they distribute a 4 through here, -8, 12, 12 and 16, -4 and 12. And then once again, we're just adding the consistent spots. 12 and -8 is 4. -6 and 12 is 6, 3 and 12 is 15, 12 and 16 is 28, -15 and -4 is -19, 9 and 12 is 21. We've got to be able to add and subtract positive and negative numbers. The next one down here, we're multiplying 5 through the first matrix. We get 15, 25, -10, -20. Through the second matrix, I can't stress this enough, multiply through by a positive 3 and then subtract. We're not multiplying through by a -3, we're multiplying through by a positive 3. We get 12, -6, 18, -9. And now we subtract the consistent spots. 15 minus 12 is 3. 25 minus a -6 becomes 25 plus 6, which is 31. -10 minus 18 is -28. And -20 minus a -9 is -11. In our last problem, we're distributing the 4 and then distributing a positive 5 and then subtracting the consistent spots. So we get 20, -8, 12, and 4, -8 and 16. We get 5 and 15, -10 and 10, -20 and 5. And now we're subtracting the consistent spots. 20 minus 5 is 15. -8 minus 15 is -23. 12 minus a -10 is 22. 4 minus 10 is -6. -8 minus a -20 is 12, and 16 minus 5 is 11. When we're solving for variables, we're distributing the number up top, or I'm sorry, the number outside the matrix C, and we're still adding the consistent spots. 4 times 4x plus 3 plus 3 times 4 equals 40. 4 times 2 plus 3 times 5y minus 3 equals 14. 4 times 3 plus 3 times 4 equals 3z plus 3. And then you see the algebra below where we get x equals 1, y equals 1, and z equals 7. You can go through that algebra that's written out right here. The next one, it's 3 times 2x plus 1 plus 4 times 6 equals that top left 45. Now we do the top rights. 3 times -3 plus 4 times 4y minus 3 equals the top right, which is 11. And then the bottom left, 3 times 4 plus 4 times 5 equals 2z plus 2. When we solve for the variables on all three of these, we get x equals 3, y equals 2, and 15 equals z. And you can plug any of these numbers back in and check them. So for example, 4 times 1 is 4, 4 plus 3 is 7. 7 times 4 is 28, 28 plus 3 times 4, which is 12, 28 and 12 equals 40. With subtraction, we just got to distribute the, now the negative stays with the number, and we multiply through that -5. 2 times 5x minus 3 minus 5 times 3 equals 9. So 2 times 5x minus 3 minus 5 times 3 equals 9. It's still the consistent spots. 2 times 4 minus 5 times 3y minus 2 equals -12. And then 2 times -2 minus 5 times 4 equals 5z minus 4. The key is this negative needs to be distributed correctly. So like for y, where the most common mistake is made, 2 times 4 is 8. It's -5 times 3y is -15y. -5 times a -2 is a +10. You make that a -10, you're going to run into problems. We finish out the algebra, it's y equals 2. Same thing on the bottom here. 2 times 3x minus 2 minus 3 times 4 equals 8. 2 times 4 minus 3 times 6y minus 8 equals negative 4. We're distributing that negative 3 to both terms, so it becomes a positive 24. Negative times a negative is a positive. We've got to distribute that negative 3 to both terms here. And then 2 times negative 3 minus 3 times 5 equals a 4z minus 1. When I do my algebra, which is worked out down here, x equals 4, y equals 2, and z equals negative 5. And if I did not say it up here, my x is 3, my y is 2, and my z is negative 4 when I work out the algebra. Multiplying matrices, it is row times column. It is not multiplying consistent spots. If you multiply the consistent spots, it's automatically wrong. It's row times column. So 2 times negative 3 plus negative 5 times 4. 2 times 2 plus negative 5 times negative 1. That's my first row. 3 times negative 3 plus 1 times 4. And 3 times 2 plus 1 times negative 1. And that becomes my second row. When I clean it up, negative 6 and negative 20 is negative 26. 4 and 5 is 9. Negative 9 and 4 is negative 5. And 6 and negative 1 is 5. When you have matrices that are 2 by 3 times 3 by 2, you're going to get a 2 by 2 answer. It's row times each column. 3 times 4, 1 times negative 2, 5 times negative 3. 3 times 3, 1 times 5, 5 times 1. That's your first row. Then I take my second row, and that creates the second row of my answer. 2 times 4, negative 4 times negative 2, 2 times negative 3. 2 times 3, negative 4 times 5, and 2 times 1. And now when I clean it up, 12 and negative 2 is 10, and negative 15, negative 5. 9 and 5 is 14, 14 and 5 is 19. 8 and 10 is 18, 18 and negative, 8 and 8 is 16, 16 and negative 6 is 10, 6 and negative 20, negative 14, negative 14 and 2, negative 12. And here's my answer. All right, and we're doing our 3 by 2 then 2 by 3 matrix. We get a 3 by 3 matrix as our answer. So 1 times 2 plus 4 times negative 1, 1 times negative 3 plus 4 times 5, 1 times 4 plus 4 times 3. And that becomes my first row right here. The second row, negative 3 times 2 plus negative 2 times negative 1, negative 3 times negative 3 plus negative 2 times 5, and negative 3 times 4 plus negative 2 times 3. And that becomes my second row. My third row, 5 times 2 plus 2 times negative 1, 5 times negative 3 plus 2 times 5, and 5 times 4 plus 2 times 3. And then when I go to clean it up, 2 and negative 4 is negative 2. Negative 3 and 20, 17. 4 and 12 is 16. Negative 6 and 2 is negative 4. 9 and negative 10 is negative 1. Negative 12 and negative 6 is negative 18. 10 and negative 2 is 8. Negative 15 and 10 is negative 5. And 20 and 6 is 26. So here's my answer. My final one, row times each column again. Negative 3 times 4 plus 5 times negative 1. Negative 3 times negative 2 plus 5 times negative 6. Now I go to my second row. 2 times 4 plus 1 times negative 1. 2 times negative 2 plus 1 times negative 6. And then that gets cleaned up. Negative 12, negative 5, negative 17. 6 and negative 30 is negative 24. 8, negative 1 is 7. And negative 4 and negative 6 is negative 10. And that is multiplying matrices. Final one, Kramers rule. We're taking 3 2 by 2 matrices and finding the determinants. We first start with the coefficients. 3, 4, 4, negative 6, and it's just cross multiplication. 3 times negative 6 minus 4 times 4. Negative 18 minus 16 is negative 34. Then we replace the x coefficients with the numbers to the right of the equal sign. So it becomes 8, 5, 4, negative 6. 8 times negative 6 minus 5 times 4 gives you negative 68. Then we replace the y coefficients with the numbers to the right of the equal sign. And it becomes 3 times 5 minus 8 times 4, which is negative 17. And then that is not the answer. You do have to finish it by taking each of these two numbers and dividing by the matrix of just the coefficients. X is negative 68 over negative 34, which is 2. Y is negative 17 over negative 34, which is 1/2. When you have the matrice that replaces the X column, that's the numerator for your X. When you have the matrice that replaces the Y column, that's the numerator for your Y. And you're always dividing by the determinant formed by the matrices of the coefficients. Second one, same deal. 5, negative 3, 6, 9. So 5 times 9 minus 6 times negative 3 gives me 63. I replace the 5 and 6 with negative 1 and negative 39. Negative 1 times 9 minus a negative 3 times negative 39 is negative 9 minus 117. That becomes negative 126. And now replace the Y columns with negative 1, negative 39. So 5 times negative 39 minus 6 times negative 1 becomes negative 189. Negative 126 over 63 is negative 2. Negative 189 divided by 63 is negative 3. And that's how we do Kramers rule.